Well, thanks for the invitation to speak and for your attention. My name's Will Sedly. So I'm a neurology trainee, nearly finished training, and have had the privilege to be on the academic track, starting with the AFP for some years now. So obviously I can't tell you everything about careers that might lie beyond AFP, but often the most useful thing is really just to hear from the experience of someone who's kind of been there and taken some next steps. So hopefully you'll find these useful in some way. So just a very brief summary of what we're going to cover. I'd like to start with really a step back and actually why we're doing any of this and even considering doing AFPs, and then my experiences in terms of where I stood, what my interests and experience were before the AFP, what I did on the AFP, the next steps I've taken, and hope, and with a little luck, what the future may hold for me. So I think what it really boils down to is, why are we doing this? It's to be in the privileged position to be paid to indulge in what should eventually be our main hobby in life, which is to conduct enjoyable and innovative experiments, meaning we enjoy the process and enjoy doing it, and it's new, it's never been tackled before, and it serves an important purpose. And I think if you can tick all those boxes, then why would you want for anything else as a sort of main activity in life, really? So it's worth bearing that in mind, because I think if there's too much deviation from it feeling like this for too long, bearing in mind there'll always be moments that things don't feel so good, then you've got to question things. So before the AFP, I think I've known for some time I was interested in the brain, and I mean the workings of the brain and the mind. In medical school, I would read Oliver Sacks and Ramachandran. I foolishly subscribed to the Journal of Consciousness Studies, which had some great articles. I rarely got around to even reading them, but it looked good on the shelf. Liked things like meditation, was interested in the idea of psychedelic substances and how they could alter one's experience of reality with such a simple chemical effect. Phenomena like phantom limb pain and how our experiences are so different to necessarily what the physical world is sometimes, and things like mirror therapy that can be used to attempt to treat these. And I really didn't know whether I wanted to be a neurologist or a neurosurgeon or specialize in non-invasive brain stimulation, even a psychiatrist or a radiologist, but something neuro, and lots of ideas, very little concrete path. In terms of actual sort of concrete experience to back this up and bolster the CV, not a lot really. I had my medical degree experience so far. I'd done a research project in microbiology, and nothing geared towards these interests. I liked the idea of research. I don't think I really knew what it was all about. Saw the AFP advertised. I was studying in Nottingham and thought, that looks quite good. Why not apply? So just to look at a bit of a map of the UK, I'd grown up in Cambridge and sort of thought about returning closer to home. Saw this post in Newcastle. Thought, well, it's kind of a step towards Cambridge. So I thought, could I live in the north? I've never really been. Well, maybe I've been once. Seemed quite nice. Yes, I can. Applied and was lucky enough to get the post. So that was great, and there were a lot of ideas and possibilities, and not really a clear sense of where to begin. So I think the purpose of the AFP is that it's an initial step. It's a kind of foot in the door. You don't have to do an AFP, but it helps get you started. Finding a research area, a supervisor, just getting some experience of the research method and techniques under your belt, and pilot data, the all-important pilot data to furnish your future applications. So the academic neurologists at the time were Professor Turnbull, or Professor Sir Douglas Turnbull now, Professor David Byrne, Professor Patrick Chinnery, and Professor Tim Griffiths. So I spoke to all these individuals, and they had very different research areas, from mitochondria, movement disorders, genetics, and then auditory brain functioning. And I think that the latter was geared most to my interest, so I approached Tim Griffiths, who was kind enough to take me on, really. So moving up to Newcastle, there were all these grand visions about all the sort of historic quayside, all the redevelopments and all these lovely views you see when you cross into Newcastle for the first time. And I think the reality was even better when I turned up at my hospital accommodation, as you see here. So when I first joined, I turned up in Tim's lab, and he was like, "Well, great, good to have you here. What should you actually do?" And I think he went out on a bit of a limb for me, and he'd struck up this collaboration with Matthew Howard in Iowa, who's a neurosurgeon doing invasive brain recordings in neurosurgical patients. Just struck up a very important collaboration. I thought, well, why not send Will there to kind of help cement this? And I think his exact words by email were, "He is bright, motivated, and largely socially appropriate." Now, where the largely came from, I really don't know. I thought I'd been on my best behavior, but he obviously saw through that, what I was really like anyway. And the response was, "Great, send him over." They put me up here, which I think certainly at the time, make of it what you will now, this was the lap of luxury. That was my hotel room for 6 weeks. And we got some nice data and things. It was not very clinically relevant, the research, so maybe not the best long-term prospects for a clinical academic. And Tim said after that project was done, "Well, what about working on tinnitus?" Ringing in the ears, isn't it? I thought. So my initial thoughts were, that sounds really quite dull. I'm interested in lots of sort of much more juicy phenomena, complex hallucinations and things like that. There's not really a local research expertise in tinnitus, 1 or 2 studies, doesn't really overlap with clinical neurology. So naturally I said, great, yes, let's go for it. And just I hadn't realized actually how common tinnitus is. And you'll see on this simple pie chart here, actually, that to truly have no tinnitus at all puts you in the minority. And then there's this very large category in black who hear some ringing in their ears if they're in a soundproof room, no other sound source, and listening to what they can hear, they do hear a very faint tinnitus. And then there's this wedge, sort of 15% of the population who have it persistently audible above background noise, and then a slice, about 2% of the population, which is still a lot of people who have a very impaired quality of life. So it's an important clinical problem. And the other thing is, you may think, oh, that this is the auditory pathway from ear to brain. That's quite complicated. When you really get down to it, actually, there's a lot more going on. You've got the cellular level processes and synaptic level processes in the cochlea where the damage may occur. So you kind of need to understand things right down to that fine-grained level. And you need to go to much broader brain networks that actually underlie perception itself and how one reacts to something. What makes the difference between someone who goes, "Oh, it's a little bit annoying, shrug, I'll get used to this," and someone whose life is ruined by it. And I think if you really want to fully understand a condition like this, you're actually traveling the length and breadth of the brain. And I think I quite quickly came to realize that and found the research area fascinating. And even just understanding the system and what it's doing in a simple, ongoing, low-level perception like tinnitus is challenging enough. So my work consisted of, well, you probably won't generally recognize this, but this is the Hexham Saltburn train, and I was staying in Middlesbrough at the time, commuting up to Newcastle. I spent a lot of time on this 2-carriage train, and it's very associated in my mind with tinnitus for a number of reasons. Firstly, it squeaks and squeals like anything because it's very old and it sounds like tinnitus. And secondly, I realized that in my long hours sat on this train, I could cause a little bit of tinnitus in myself by doing forced jaw contractions, clenching or forward protrusion by activating the pterygoid muscles here. I do not recommend you do this because initially this would elicit a tinnitus-like sound at the time. What I came to find is I've done this so much over the weeks and months that the tinnitus became permanent and has never gone away since. So as I say, I really don't recommend this. Never bothered me, but ideally would probably not be there. So I did a research study that I came up with using this jaw movement phenomenon to make people's tinnitus louder. And you can examine them in a state where it's louder, where they're making the jaw movement, and where it's quieter. Contrast those, did some EEG recordings, and it all looked very promising at first. But eventually it turned out what we were seeing was just a product of the muscle activity and not underlying brain activity, which can be very hard to distinguish, and the controls just weren't pushing as hard. So unfortunately, that study and everything I'd sort of invested in for the second half of AFP really didn't come to a lot. So by the end of the AFP, I was left thinking, well, I've got really good colleagues who I enjoy working with. I found an enjoyable and important, interesting research area. I've sort of taken my own angle on it, but it hasn't worked. So where to go from here? And, you know, when you all invested in one project and things don't go well, it can get a bit dispiriting. But I thought, no, I enjoy the process and things are bound to work in the end, and thought, well, I should keep at it. I'll try another approach and go until something works. So I applied for an academic clinical fellowship and was lucky enough to get that. And in the ACF, I took further attempts. I repeated the same study with a different recording modality. This is MEG, or magnetoencephalography, which measures magnetic fields. It's much better at separating muscle activity from brain activity, but still the same problem was there. We couldn't be confident it solved it. And had another go using a different way of making tinnitus louder and quieter by using sounds to temporarily modify the tinnitus. And that worked very well. And it actually yielded some very interesting results, which I didn't fully understand at the time. But back at the time, the prevailing theory was you've got these high frequency brain waves called gamma oscillations in the auditory cortex, and really those are what generate the tinnitus and that perception. And if that's the case, then when tinnitus gets louder, they should go up, and when tinnitus gets quieter, they should go down. And what I found is when, sure enough, if tinnitus goes down, these go down as expected. But if you make the tinnitus louder, they also go down, as in you can have a positive correlation here in red and yellow, or a negative correlation, depending on the exact context. And that really shattered the prevailing theory. And the results were quite striking and hard to ignore and reproducible across many individuals. So that kind of extinguished a number of bonfires as my first published foray into the field. And I suppose I didn't make myself many friends at first. But we're all friends now. So that was a good high note. I thought, you know, finally, this is something really important and useful in the field that I've come up with out of my own research direction and ideas, really. And I had a lot of things I was excited to do next. And I thought, oh, well, for a PhD fellowship, I can do this, and I can do some spectroscopy, and I can do some MRI, and I can do some MEG and some EEG. And so Tim Griffith said, okay, look, that's a shopping list of ideas. You're going to struggle to get that funded. Make it hypothesis driven. So while I was out walking the dog one day, it finally clicked, and I put together a plausible hypothesis that linked all the different strands and sort of packaged it and sold it, and was fortunate enough to get funded. And I carried out my shopping list of ideas, and it didn't quite conform to the hypothesis, which is kind of unsurprising because the hypothesis was retrofitted. So it should have been no shock to see that wasn't what turned out to be the case. But I got some nice results of various forms. And then in the last 2 months before I had to submit, and on that note, if anyone who does a PhD as a clinician in future, remember this, and remember this. Write up and submit before you go back to clinical training. No ifs, no buts, even if you've not finished, even if you don't think you've got enough, because it is nigh on impossible and will make your life hell afterwards. And it's so easy to write up when you've got all your time dedicated to it. So I said, last 2 months, I'm going to conduct research. The last 2 months is write-up time. And so I just sat there, read my results, read the literature, and I thought, well, how does this all fit together? And I had some sort of ideas, but I thought, you know what? I knew what I needed. Now, I don't know if any of you have kids, but this is a popular children's book by the author of The Gruffalo called The Scarecrow's Wedding. And in what they want to have, the whole theme of the book is they want to have the best wedding ever, the best wedding yet, the wedding that no one will ever forget. I had a young child and was reading this book a lot to them. I thought, what I need is a figure. I need one figure that puts everything together, the best figure ever, the best figure yet, the figure that no one will ever forget. And so I started with some sketches that were very rough, just putting in everything I'd found and the other key bits from the literature that I believed, and just thought, well, put them in one place, see if they make sense. By about 7 or 8 iterations, I ended up with this. It's not quite the figure that no one will ever forget, it's the figure that no one will ever comprehend. But it did the job, it crystallized the thoughts, and suddenly everything made sense to me. And this culminated in what's been a very influential theory I've come up with to explain tinnitus and all the bits that never made sense before, which has kind of been a springboard into a prominent profile. And so I started out by making enemies and telling people they were all wrong. And then I've gone, actually, everything does work and you're kind of all right, and have made some friends since. In a nutshell, tinnitus, the first bit of tinnitus, is a little bit like these random black dots, but in the auditory system. I don't know if any of you've seen this picture, but generally at first you don't think it's anything but abstract or random dots, but eventually if you look hard enough at it, you see what it's about. And if you haven't seen it already, it's a Dalmatian dog, and you see its head here, it's sniffing at something, there's a tree over there. And once you've seen it, once you've recognized a meaningful pattern, you can't unsee it. And tinnitus is basically like seeing a pattern in random brain cell firing in the auditory pathway. And once you've seen that pattern and given it a meaning, you can't unsee it or unlearn it. And then all you have to do is explain things like, well, the hearing loss and everything that predisposes you to it is just kind of cranking up the volume and making these dots more and more vivid, and it's easier to see the pattern. But the key second step is whether you see the pattern or not, and that gets lodged, and then you're stuck with it. And the rest was just about actually laying down the brain basis for how this occurs. So after my PhD, I applied for an academic clinical lecturer post, which was quite handily available. It's another post that lets you do kind of 50-50 academic clinical training in blocks, or I actually did days of the week, but it really depends on what your kind of research is. And I thought it was a nice position to generate some hypotheses from this model I'd created and test these. I was lucky enough to get funding for a PhD student who's still working with me now. I tried a few tacks, and one of the approaches does seem to have been successful in testing some of the predictions laid down by the model, which may be of practical benefit in actually diagnosing or measuring tinnitus. And then at the same time, actually, it's amazing how when you're at an early stage in your career, you've just got all the time you want to focus on your research, get stuff done, you can be really efficient. That gets harder and harder because you're asked to review papers, to sit on committees and bodies, to have discussions and collaboration with other researchers, give talks and things. And it's necessary and good and nice in a way, but it's quite an upkeep, and it's astonishing how much of your time you end up giving over to these things. And then again, you get a part of each of these academic posts is to get you the pilot data to get you onto your next step. And by this point, the next step for me will be an intermediate fellowship like MRC or Wellcome Trust. So I've applied for these. Who knows what will happen? They're immensely competitive. But all being well, I would eventually obtain one of these posts. And then it's kind of about the ongoing challenges and match up a research interest in tinnitus with a clinical practice in neurology. There's a lot of overlapping conditions that probably have a very similar basis and mechanism that we do see in neurology, which include pain, migraine, and even fibromyalgia that overlaps across a lot of specialties. So eventually it'll be a little bit of sort of lateral expansion into these areas, all going well, but we'll see. You have to take it slow and not overreach for fear of doing things badly. So that's about it. That's my experience in a nutshell. Thanks. Well, this is pre-recorded, but in advance, thank you for your attention. I look forward to any questions or discussion we may hold afterwards. Thanks.
Hi, so my name's Zaid. I am an F1 in West London, and I just completed the Medics Academy training in teaching day 3 course.
I think it's structured in a really nice way with a lot of resources you can permanently access. The course isn't over after 3 days. You've got a ton of online content that you can always revisit, and I think that is fantastic.
I thought it was a great way to learn through having a full day at the start and then 2 later days of self-study. It really allowed for flexibility and allowed us to fully engage in the course.
It also made me feel better prepared to deliver teaching remotely or digitally. It's really interactive with a lot of small group feedback session, exchanging ideas and learning people's perspective.
After actually doing this course, I realised that teaching is more of a science, and it's really important to get clear feedback so that you can improve your teaching.
This course also encouraged me to think thoroughly about what my audience actually wants from my teaching session, and also how I can keep them better engaged.
Really great and fantastic to get such fantastic lectures from experts in the field throughout the 3 days.
It was also interesting to learn from others taking part on the course because we all have different levels of experience, so it was interesting to gain their perspective on things too.
I learned not just about different style of teaching, I also learned about what is medical education, how to build a career in medical education.
Overall, I learned a lot from the teaching course.
I think it's a really well done course.
I really enjoyed it.
And I really found it very enjoyable.
That's what I thought of the whole course, and I really enjoyed it, and I would recommend it to other people.
So thank you for letting me participate.